So we're back looking at hydro, and we said that hydro is a resource that is incredibly useful because it can fill in the gaps with a large wind and solar resource production system. For example, if it's a calm night, it's a little tough with wind and solar together. Um, Now, I don't want to overstate, though, that problem. We're later going to see a video to show you how regional and continental scale grid integration can pretty much solve the intermittency problem of wind and solar, along with a number of other things. It's really not mysterious. In fact, in parts of Europe, it's already being done at quite a high level. But nonetheless, hydro is a big part of that potential story of integrating solar and wind into the grid. One of the challenges with hydro and wind integration is simply that we get a peak of both in the spring, late spring and early summer here in the Pacific Northwest. And so sometimes we have more electricity than we need and that even California wants to buy. That is a little rare, but it did happen a few summers ago. So but that's something that's not an unsolvable problem at all. We'll see why later. We just need to plan and as a rational society, make decisions. Okay, that may be too much to ask, right? Humor intended, okay? So the next thing about hydro we want to say is that hydro is, as we mentioned, is unlikely to grow in capacity. If anything, we're removing some dams, the Condit Dam, the Owa River Dam, dams. There's two of them there. We're going to look at those later in this unit. And there's talk of removing dams on the Snake. So I don't see hydro growing in production. If anything, maybe shrinking. Now there's some small hydro possibilities in some watersheds that are already being utilized. I've seen some of those in the east side of the Cascades hiking. So the other thing is that, well, you're studying this, you can tell me this, right? The anadromous fish impact salmon, right? So dams are pretty tough on salmon unless they're planned properly, and in many cases they weren't. So we lost a big part of our whole watershed for salmon when we built dams on the Columbia River, as the ladders were not on the upper parts. So, and then there's that centralized production problem as well we talked about. In a world free of terrorism or free of regional grid blackouts would be another kind of risk from very centralized production. Yeah, so that's something to think about anyway. Petroleum is our way we get around still, for the most part. 90-some% of us are getting around that way. Yes, we can do it with natural gas, and some vehicles have that option, and municipal buses and some service vehicles for some large organizations are using natural gas. But petroleum still is mainly the one for getting around. And it used to be the cheapest source for transportation, but now it's not. I'm going to say it here and I'll say it again later. Per mile, cents per mile, if you just look at energy cost, gasoline versus electric, if you're filling up at home, so to speak, charging up your batteries in electric cars, way cheaper per mile. But we'll get to that exact example of that later on. What I said probably surprised a lot of you because it's not something that we don't really think about what electricity costs. But remarkably, we're in a very different competitive environment. So we're going to find out that price isn't everything. All right. Well, we don't have petroleum in this region at all. It does come from east of the Rockies, so it's not like we have to import a lot anymore, although we still have some imports and some exports of oil. It is a U.S. strategic issue, as we've described, a national security issue, and the cause of global recession. So you have all of that. If we had a locally and regionally sourced supply that we could drive around our vehicles in, wouldn't that be better? We wouldn't have to have all these complex geopolitical arrangements with Europe and the Middle East and so on. And in fact, even with Russia, there's a lot of pieces to this petroleum thing beyond really what we're doing here, other than I'm going to kind of knock it a little bit here, because we make no money at all on extracting it here in this region, and it's a climate change problem. So if we can find some other way to do it, so much the better. We're going to come back to that later. Okay. Natural gas. Okay. So it's the most flexible of fuels: industrial, home heating, business heating, water heating, electricity making. The recent hydraulic fracturing breakthroughs, fracking, sometimes they're called, have expanded North American reserves and supply dramatically. This is an amazing story. Something to jot down on this one. I'll tell you a story. I've been teaching this class for 20 some years, and in the 90s and all the way up through 2009, well, 8 actually, the story on natural gas was that we were running out of it in the United States. We didn't have enough. And in fact, we were importing it. We were using like 20% of the world's supply, and we had 3% of the reserves. It didn't make any sense. So the big thing we talked about in this class 20 years ago was, will we build terminals to import natural gas from other parts of the world? So there are all these proposals, natural gas import terminals. Yeah. Okay. Now we got some from Wyoming, as I mentioned earlier, and some from Alberta. Those are the main supply areas. Now there's a little natural gas fields up in Mist to Oregon, but not of any note production-wise. We do store quite a bit up there. But here's what happened. In 2009, the full-bore recession hit. There was a drop in demand for natural gas. The price plummeted. It had been relatively expensive. But at the same time, there were some folks that have been working on fracking, and they kept getting better and better and better and better at it. The Permian Shale, the Bakken Shale, some other places came online for oil and natural gas. And what's happened subsequently is that we produce more and more and more of it, and it's pretty cheap. Now, recently the price started edging up again, maybe a year or so ago, but it was really cheap, and the continent has an excess of it. And so now those same places where we were going to export it to the rest of the, import it from the rest of the world, are now being proposed as export terminals because we have so much on the continent. Okay? That's an interesting turnaround, isn't it? Wow. I just never had imagined such a thing would happen. So we may come to that issue a little later on. Should we be exporting our natural gas? We'll be building terminals that need 20, 30-year payoffs in the era of climate change, or should the world be figuring out another way to run itself? Okay? So when you build a big terminal, it's a long-term commitment to extract the fuel and use it. Something to think about. All right. So it is cleaner than coal somewhat. Generally speaking, I think people agree on that. Cogeneration is where you reuse the heat to generate again, or you use the heat in a space, in a building to warm it. So you get a thermal benefit and also a generation of electricity benefit. It can be decentralized for electricity generation, smaller plants, in other words, and they are smaller than the coal and nuclear plants, but generally not super decentralized. It can be used and is used for firming intermittent power streams from wind and solar. It's been pushed as the bridge fuel. The way we were going to get to a cleaner energy supply, we would build out lots of solar and wind production, and because the smaller plants, natural gas plants, can be turned on and off easily, we can make a system where we always have reliable electricity using natural gas to fill it in. That's called firming power. Yeah, so this bridge fuel concept was pushed even by groups like the Sierra Club not that long ago as an alternative to coal. It is arguably somewhat cleaner, although we now know there's a lot of leaks of gas from the wells and infrastructure. Not clear how much better it really is. The other problem you want to jot down is when you put it on a tanker and send it to the rest of the world. Like, let's say you export natural gas off the Pacific coast here, say from Oregon, where the terminal has been proposed. When you compress it and put it on a giant tanker, it takes roughly 30% of all of the energy in the natural gas itself to compress it enough to put it on a tanker to make the trip worthwhile. So what that means is that the net emissions rises by roughly that amount for the system, because you have to spend so much of the energy produced just to put it in a shippable form. So when you do that, the advantages that natural gas have over coal pretty much disappear, even ignoring the leakage of gas out of these wells, natural gas. So I'm going to say here that if we're wanting to be serious about climate change, these are probably really bad ideas. We could do better than that, okay? And we're going to see how we could do better than that later on, all right? So coal, quickly, it's not a big part of Pacific Northwest energy. Most of it's that's used in the region has come from Montana, Wyoming. For example, in the plant in Boardman that just shut down. There is a plant in Centralia, by the way. If you take I-5 north, you're not too far from it. That's another one in the Pacific Northwest. Okay, but again, big problems. Well, first the pros. It tends to be stable in price, pretty cheap. If you have an existing plant, the material cost puts the cost of each additional unit of electricity produced up to it's 3 to 4 cents per kilowatt hour roughly. Doesn't include the cost of building a new plant though, or a plant and amortizing that. And we're going to see some cost stuff in a bit. Projected reserves are big, so probably have enough. That's not the issue. Okay, it's a bad air pollutant, a limited regional supply, and in that you want to also jot down in the cons. Yeah, climate change. It is the most polluting, if you call carbon dioxide emissions pollutants. Okay, it produces more carbon per unit of energy than natural gas, usually, as we talked about already, and it also creates lots of local pollution as well. Although the newer technologies are somewhat cleaner. All right, nuclear. Okay, it's a fairly small part. There's a plant operating in the Hanford area. It is another kind of large power plant, so it's centralized production. It does have a fairly high predictability of supply. It's used for base load, which means the kind of 24/7 minimal amount that we're going to need any time of day or night. You don't really turn off nuclear plants and on quickly, so you can't really vary much their production over a period of time. There's no real theoretical supply limitation for nuclear. The mining pollution could be worse, could be better. You always have that no matter what you're extracting. And you also have some of that, by the way, with renewables, with some of the rare earth materials that when you're making wind turbines, or when you're making solar panels, or when you're making batteries for cars. So it's not like we can totally get away from that by getting away from the fossil fuels anyway. It does lower water quality. All thermal plants heat the water up. That's why they're always located near water supplies, like the one in Hanford was along the Columbia River, just up from the Tri-Cities. So you have this kind of, it doesn't consume the water, but it does degrade its quality. Remember, salmon like cold water, not warm water, and this just makes a warmer summer even more detrimental to water quality. Okay. So then there's a whole bunch of other stuff on nuclear, but just real quickly, a lot of people worry about if there's a major meltdown or earthquakes, what would a subduction zone earthquake do to a nuclear plant? Those kinds of risks. So here's what I'll say: extremely unlikely in the next 10 to 20 years there will be one built in the Pacific Northwest. Okay, there are some designs they've worked on down at OSU, smaller ones, or ones that reuse the fissile material from the first run through. Some neat concepts. One of the problems is nuclear is very expensive. Another is it takes many, many years, like up to a decade, to build them. And by the way, you already know part of that story from Organic Machine. Go review it if you need. I'm not going to spend more time on that here. Okay. And then there's conservation, which we'll pick up in the next